what the first step I want to do is get that constant over to the other side. So I'm going to subtract 4 from both sides. I get x squared plus 5x equals negative 4 because I subtracted 4. All right, now I want to find a number in here that makes this a perfect square trinomial. How do I go about doing that? I take the 5. What do I do with it? Divide it by 2 and then square that. So it's 5 halves squared. 25 fourths. So I'm going to add 25 fourths here and add 25 fourths here, okay? And you may think that was just awful. You introduced a fraction. Well, watch what happens. Is this a perfect square trinomial? Is this a yes? Perfect square? Yep. Is that a perfect square? Yeah, 5 halves would be 25, the square root of 25 fourths. And then is this a yes? Now, you don't have to go through this process every time, but here's what I have. I got 5 halves times x doubled. What's 5 halves doubled? 10 halves. What's 10 halves? 5. So I get that number. You don't have to run through that process, but I did make this a perfect square trinomial. So what goes in here? X plus 5 halves, whatever. So square root of that, and it's plus because that's a positive sign. If this were a minus sign, that's a minus sign. So that's where you get there. Okay, now here you get, oh no, adding and subtracting fractions. So can I just add them the way they are? No, just like we learned in our, last chapter? Rational numbers, you got to get a common denominator, which is what? 4, so I got to change this to negative 16 fourths. Make sense on that? So I'm going to change that right now. Negative 16 fourths. Okay, so now I can add the numerators. So it's 25 plus negative 16. 9 over the common denominator 4. Okay, so we got that. All right, then I still want to find what x is, but I got it in this format, so now I can do it very quickly, easily now. How do I get rid of a squared? What I do to one side, I got to do to the other. I got to keep it balanced. So I end up on the left side with x plus 5 halves. And then here's where you have to think, if I square rooted 9 fourths, there are technically 2 numbers that fit. So I put plus or minus. What's the square root of 9 fourths? 3 halves. And what I mean by the plus or minus is that it's either plus 3 halves or negative 3 halves. Both of those are the square root of that technically. So we have to come up with 2 numbers with that. Square rooting of a number. Okay, but I still need to find what x is, so I subtract 5 halves from both sides. This is where just be careful with your signs. I end up with x equals, all right, I'm going to start off with 3 halves, positive 3 halves minus 5 halves. So 3 halves minus 5 halves. That's one solution. The other solution is negative 3 halves minus 5 halves. Negative 3 halves minus 5 halves. All right, so what's 3 halves minus 5 halves? Negative 2 halves, which is actually negative 1. So I get negative 1. That's one answer. And what's negative 3 halves minus 5 halves? Negative 8 halves, which is negative 4. So those are my 2 answers. Oh yeah, and you could have found that out by factoring, right? Oh, what? But can you do that on all these problems? I mean, no, it doesn't happen. So far, on factoring and solving this equation, I could have just straight up factored x plus 4, x plus 1, and I would have gotten those answers. Or I can use completing the square, right? So far, which one's easier to do, honestly? Factoring. But on this lesson, we're learning completing the square because we get problems such as this. Did I have a question beforehand? Yes, sir.
Are the quizzes graded or no?
No.
Somebody already asked that question.
That's okay. He just wants to rub it in that I haven't graded it. I'm sorry. I will try to get those done. Thank you guys. And your test, I was going to put on Friday, but I'm like, you know what? Push it back to Monday, second period. So you'll get your quizzes far in advance for that one. All right. So here's the second one I want to give you. Can you factor that one? No. But can you find out what the solutions are? Yes, because we have complete the square.
Oh, so this is like the ones that like we
Awesome.
factor back in like the lesson before, or not the lesson before?
Yeah. Remember you would say no real solution or unfactorable or no roots. Technically what we should have been saying no real roots, or no rational roots. So now we're going to find no matter what they are, unless you can't find it at all, which is possible, which happens. There's nothing. We made up a problem and it was bad. It didn't work. All right, so if I can't factor, it's not a perfect square trinomial, what do I do first? Olivia?
You subtract 2.
From both sides, so I get x squared plus 6x blank equals negative 2. I just put a blank because I'm going to fill that blank in with something that makes this a perfect square trinomial. So how do I find that last term, Daniel?
You cut the leading coefficient of the middle 1 and half and then square it.
Yeah, okay. I actually like that you use some different words. I'm going to say I cut the b value in half, and then I square that. B value in half and square it. 3 squared, 9, positive 9. And I add 9 to both sides. That's the magic number. Because is this now a perfect square trinomial? It is.
Yeah.
And what goes in there? Yeah, and if you're not sure, what is it? It's always a square root of that, or it's right here. It's this number just goes in there, or square root of that. Okay. And then that's 7. All right, that's nice, right? No fractions. Yay. But what do you have to do to solve for x still? Take the square root of both sides. What does a square root and a square do to each other? Because they're inverse operations like adding and subtracting, multiplying, dividing, they undo each other. So I'm left with x plus 3 equals, say it the right way, plus or minus the square root of 7. Now, do you know what the square root of 7 is? Exactly? No. Can you guess? Give me a guess, an estimate.
2.5.
2.5, okay?
2.6.
2.8? 2.6? Okay, anyone have a calculator? I don't know what it is.
2.8.
2.7. I'm going to go 2.7. I don't know if I'm going to...
2.65.
2.7. 2.73. Oh, go ahead. Yeah, it's in the back of your book. What is it?
2.646.
646. Okay. I don't know who said it. Yeah, 2.6? Okay, good. All right. What I want you to know with that is don't be scared of square roots of 7. You're like, people in your grade and above in high school, they're like, square root of 7? No idea what it is. It's about 2.5. 2.5 is not bad. 2.6 is better, obviously. So you want to have an idea of that, but that's not my answer. What does x equal? First, I subtract 3. Now, something we're going to look at later. This is because we reversed the chapters. But here I'm left with x. There are 2 answers, but I'm going to write it like this. I'm going to write negative 3 plus the square root of 7, because that's standard form. We call it the the rational and the irrational part. So rational, then irrational. And what's the other solution? Negative 3 minus the square root of negative 3 minus the square root of 7. So these are the 2 solutions.
Why don't you do like 2.6?
Because you technically want to say the exact answer. The exact answer is square root of 7. You can estimate it. You can't, because they're irrational. If it's irrational number, what do you know about that irrational number? It keeps going on forever, and it never... Okay, it keeps going on forever and never repeats a pattern. So if you want to be exact, you say it like this. If you want to round it, then you can start estimating some numbers. Okay, and then I'll give you a nut.
How many digits have you made?
I bet it goes into billions, trillions digits. There's a program for pi, for example, irrational number, where you can put in any number, like I put in my birthday, 93 blank blank. 9386, I do 9386, and you can find that sequence, grouping of numbers in pi somewhere. And it'll say like it's in the 10,000th decimal place. That's where it starts, 9386. So any numbers can be found in there. Just you gotta know. So I'm sure they got billions, trillions. Yeah. What's your birthday, Will? Give me in the format I gave it to you.
11-1-05.
You were thinking about maybe your brother. You're like, oh, my birthday. 11 1 oh, so you can say like 11-1-05 or 11-01-05, and it will find it in pi somewhere. It's in there. I just don't know where. I don't know. So I think that's kind of fascinating because it's in there. Just it doesn't end. It really doesn't.
When is two though?
We're trying to find it in this. At this moment, we are trying to find
Is there a
it.
place in pi where it goes 1, 1, 1, 1, 1, 1, 1, 1, 1?
No.
Why?
Oh, pi is so good. It's not made up. It's an actual number.
Circumference or something. Yeah, pi multiplied by diameter equals.
Okay, let me give you another one here that people might struggle with. Well, actually, can you get 2 through 10 even? What was one that you struggled with?
10.
I heard 10 a couple times. Number 1, I hope you didn't struggle with. I heard 8.
Let's go 2. Because it is 2.
How many of you would, your options are 10 or 8? How many of you say number 8?
7 or 9.
Okay, number 10. I'm going to go with number 10. Oh, yeah. Okay, do it with me, guys. 3x squared.
Will I have to do this homework that I did on Friday?
Say that again.
I need to make up the homework.
Yeah, so you're going to have to do it, and I'm doing a couple with you. Did I do one? Oh, I did do one with you guys already. Oops. All right. My bad. I mean, not my bad. You're good. I don't know. Okay. Sorry? I just picked problems. Yeah, that one looks like a one type that they might not understand fully. All right. This is number 10. Okay, I'm going to write it in standard form. Oh, yeah, this is nice. Okay, but before I start completing the square and doing all that, do you notice my lead coefficient is 3? I don't want it to be 3. So divide everything by 3. Off the top of my head, I'm not sure. But let me see. Number 10? Yes, you can. How about this? I will give you a section on that test that says you could solve it however you want. Right? Because that's what I want. Yeah. No, I mean, but you're still gonna have to know this. And I'm gonna give you oh man. When I first started teaching the next lesson, I had to do completing the square with no numbers coming up in just a bit. So that's hard. And when I first had to do it, I'm like,
Working backwards.
no. Working with the quadratic equation, but no numbers. So I'm going to do that like A, B, and C instead of numbers. But we'll get to that. Well, we're gonna make it a thing. It's a cool thing to do nowadays. All right. I got x squared plus 11 thirds x blank equals 4 thirds. I got a blank. All right. On this one, do you notice that we've been dividing by 2? And I need you guys to get this down because this is an important fact for math. Dividing by 2 is the same thing as multiplying by 1/2. Do you believe me on that? Okay, let's take the number 10. Jack, what's 10 divided by 2? Okay, 10 divided by 2 is 5. You agree with me? No tricks on this one. What's 10 times 1/2?
5.
So dividing by 2 and multiplying by 1/2 are the same thing. So I'm going to multiply this by 1/2 and then square it.
Why does it matter if they're the same?
I mean, well, because some people are like, how do you divide 11 thirds by 2? Well, it's same thing as multiplying, which, all right, yeah, you just multiply the bottom, the denominator by 2. All right, so I get 11 sixths squared. So what's 11 sixths squared?
121.
Okay, so I'm going to add 121/36 to both sides. which seems like a nightmare to some of us, but it's not. By the way, I was tutoring a student yesterday, and they didn't know, this is a ninth grader, didn't know 11 squared, 11 times 11. And I looked at her and I said, that's not even cool. That's not cool at all. Why? Sorry? I'm not going to say, no comment. So I said 11 times 11 is, and the blank look, looking up into the air, finding that number, not going to find. Okay, you got to know these. In fact, perfect squares, you better know those very well. Because another one was, what's the square root of 225?
15.
That's not a perfect square, is it? Wait.
It just looks like.
Yeah, no, but it's not. It's not. Okay, that's the process going on that you got to know those because it makes your life easier. Anyway, I'm going to work up here, see if I can squeeze everything in there. All right, is this a perfect square trinomial? Believe it or not, it is, which is, it's x plus, what do you think
11 thirds.
11 sixths plus 11 sixths squared equals, all right, so then we have to add these two up. So you got to get a common denominator. You're like, oh my goodness. Well, what's the common denominator?
12 or 30.
36. So I multiply this by 12 over 12. So I get 48 36. Oh, I can just do this. 48 36. What's 48 plus 121?
169.
Ah, man, I've never seen that one before. Over 36, the common denominator. All right, how do I solve that? Square root both sides. So I get x plus 11 sixths equals plus or minus.
13.
Wait. Are you guessing? Oh.
13.
13 6, because you know your perfect squares, that's easy to find out. All right, so I subtract 11 6 from both sides, and I'm left with two answers. One is negative 11 6 plus 13 6, and the other one is negative 11 6 minus 13 6. And sometimes they come out to nice integers, and sometimes they stay as fractions. It doesn't matter. So what am I left with at the top? I'm left with 2 6, which is 1/3, and then negative 24 6, which is negative 4. Done. Yeah, that could have been factored using bridge.
Do you ever have to check it, like put the numbers exactly in the top one?
Huh?
Do you ever have to check it, or are they always just going to be right?
They're gonna work if you did it right.
Can I go over 8?
Are we ever gonna finish the problem that we started? Number 7.
Oh, number 8.
Yeah, that one. Are we gonna finish the problem that we started?
Which one?
It was the x squared plus 6x. Then you changed 2 to a 7, then we did a completely new problem.
Oh no, we finished it. Were you here? One? This one.
Wait, that's 8?
Yeah, but where's the 9?
Remember, you 3 squared is 9, so you add 9. These two added together 7 square root. Welcome to class. All right, I'm gonna give you about, I don't know, 10 minutes. Finish up your homework or change things that are not right.
We can't change the
Bye, Swivel.